In our second video of lesson 3, we're going to look at composition of functions, which is another operation that we can do with functions. So we've got f of x, our first function, is equal to 6x squared, and g of x is equal to 4x plus 5. And we're asked to find the following. And all of a sudden we see this crazy symbol show up. We've got the f of g of x is how you say that. And the second one, we want the g of f of x, and finally the f of x. To help understand that notation, I want to look at a little diagram that I've made. Composition of functions is like putting two functions together. And if you think of a function as a machine, I've got input, I've got output. And what's going to happen is that input and output is going to run through two different machines at the same time. So here's what happens. I'm going to take an x value and plug it into a machine. So in this case, I'm looking for the f of g of x. That means that function g is the first one that x is going to go into. So x goes into the function, and function g, remember this letter is just naming the function. So x goes in, it's my input. Something happens, and when I'm done, I have an output, and usually we refer to that output as the g of x, which means the value of function g when I plug in x for the input. Then what happens is I take that output, whatever it might be, and I'm going to then plug that in as the input into a second function. That function being function f. So again, something happens in my function machine. It takes the input that it was given and it spits out a new output. That new output would be considered to be the f of g of x. So g of x is the input in a new function, which happened to be function f. Now if I was going to do this numerically, let's say I have these two functions and I want to find the f of g of 2, perhaps. What that means is that we would take 2, the input, and plug it into function g first. I take 2, plug it into g, and see what I get. Well, 2 times 4 is 8, and 8 plus 5 is 13. So I'd have the g of 2 would be 13, which means then I would have to take the f of 13, which means because 13 was the output of my first function, I'm going to take 13 and plug it into the second function, which is function f. So 13 then goes in here. 13 squared is 169, and then when I take that times 6, I end up with 1014. So that would be the f of g of 2 in this case. Now, if we're asked to find the f of g of x, that means to compose the two functions. I don't have a number to plug in. So what I do instead, let me erase this, is I'm going to plug in one function as the input into the other. The f of g of x means that the g of x, which is this function right here, is going to be the input that I plug in for x here. So here's how I typically write this out. I know the f of x is 6x squared. So what's going to happen is I have 6 times, and I'm going to replace the x because x is where the input belongs. And if my input happens to be a different function, I'll just leave it blank for now, put it in parentheses. So 6 times x, which I replace with g of x, this function right here, 4x plus 5, squared, because that's what happens to the input. The input gets squared and then multiplied by 6. So 6 times the quantity 4x plus 5 squared. There would be my composition of functions. This would be the f of g of x. Now we could certainly FOIL this out and simplify it a little bit. I'd have 6 times in parentheses the square of this binomial. Using our rules, we'd square the first term, multiply the two together and double it, and then square the second term. And then probably distribute the 6, which would give us, change color here, 96x squared plus 240x plus 150. And here you'd have a function that, before when we found the f of g of 2, we had to plug 2 into 2 different functions. Well, if I had this function, which is the composition, I could plug in 2 and I'd get into this function, I'd get that same 1014 number that I got, plugging it into 2 functions back to back. Let's try another one. Now this one, we're going to go the other direction. We're going to find the g of f of x. So that means that f is going to be the input into function g. So I start by writing out g, but leaving space where x was. So 4 times something plus 5. Well, that something happens to be the other function, which is 6x squared. So I plug in 6x squared where x had been in the initial function. Simplify if possible. Well, 4 times 6x squared is 24x squared. And then I got plus 5 at the end. So that would be the g of f of x. And the final one, the f of x. Here we're actually going to take the function and plug it in to itself. So the f of x is 6 times something squared. So I'll start with that, 6 times something squared. And then the new input is the f of x, which is this function. So 6x squared is going to be plugged in for x in that function, like so. Now careful as you simplify this one. This 2 on the outside, and I'm squaring this expression so that 2 applies to the 6 and to the x squared. 6 squared is 36. All right, this 6 is going to stay on the outside. So I have 6 times, in parentheses, 36 x to the 2 times 2 is 4. 36x to the 4th. Now, because it's 6 times 36, I could simplify it a little bit further and write it as 216 x to the 4th. But that would be the composition of two functions, the f of g of x, the g of f of x, and the f of x.